Now we'll use the equation involving cosines and denominators. As before, the question is, on a Mercator chart, the scale at 54 south is 1 to 2 million. What is the scale at 25 north? The basic equation is denominator at latitude A divided by denominator at latitude B equals cosine A over cosine B. However, rearrange it slightly to make the unknown denominator the subject of the equation. This gives us denominator A equals denominator B times cos A over cos B. Always put your unknown on the left-hand side of the equation. In this case, that's the denominator at 25 north. You know what the denominator at 54 south is. It's given in the question. It's 2 million. You can write them the other way around if you like, but it will involve you in more equation rearrangement and more chance of making a mistake. Put the unknown on the left side and keep it simple. You have now sorted out which one is A and which one is B. A is latitude 25 and B is latitude 54. Put them in. It now becomes a very simple calculator operation. 2 million times cos 25 divided by cos 54. It gives precisely the same answer as the other method, about 3.1 million. That's the denominator. Don't forget to write it down as 1 over in order to make it a representative fraction, which is what the question asked. This is a lot quicker than the other method. The last type of problem is, given a fixed chart length between meridians, calculate Mercator scale at a specific latitude. Again, let us look at a worked example. On a Mercator chart, the chart length between two meridians, 160 east and 160 west, is 30 centimeters at 30 south. What is the scale of the chart at 30 south? There are two ways of doing this, and there is very little to choose between them. The first is to treat it as a departure problem. Scale is defined as chart length over Earth distance. In this case, the Earth distance is the departure between longitudes 160 east and 160 west. Take the shorter departure between the two longitudes, in this case, the one crossing the Greenwich anti-meridian. In other words, the change of longitude is 40 degrees, not 320. Now substitute in what you know. The chart length is 30 centimeters, and the Earth distance is departure. The departure is change of longitude in minutes times cosine of latitude. The change of longitude is 40 degrees, and it needs to be multiplied by 60 to convert it to minutes. And the latitude is 30 south. This gives a departure of approximately 2,078 nautical miles. We now need to get everything into the same units, so we'll convert our nautical miles to centimeters. Multiply by 1852 to get them into meters, and then by another 100 to get them into centimeters. And then, as discussed in the lesson on basic scale, evaluate the denominator first and then divide by the numerator. When inverted, that gives a scale of 1 to 12,831,032. This method had little to do with Mercator charts and is essentially a scale and departure problem. The other method is to treat it as a Mercator scale problem. Find the scale at the equator as a normal representative fraction and then convert it to the scale at 30 south, like this. Firstly, find the scale at the equator. Write down the normal representative fraction equation. Representative fraction equals chart length over Earth distance. The meridians of a Mercator chart are parallel. If the chart length between two of them is 30 centimeters at 30 south, it will also be 30 centimeters at the equator. So, at the equator, 30 centimeters represents 40 degrees of change of longitude, and each degree of longitude is 60 nautical miles. So the departure is 2,400 nautical miles. Now get everything into the same units as before. Multiply the nautical miles by 1852 to convert to meters, and then by 100 for centimeters. This gives the scale at the equator as 1 to 14,816,000. Now we simply have a normal Mercator scale change problem, just like example 1. Scale at 30 south equals scale at the equator times secant 30. Substitute the scale at the equator, which we have just found, and write the secant as 1 over cos, and again we get the answer 1 to 12,831,032, about 1 to 12.8 million, just as before. There is a variation on the previous type of exercise, which appears to be more complex, but in fact is just as simple. As before, let's look at an example. On a particular direct Mercator wall chart, the distance between 180 degrees west and 180 degrees east meridians is 133 centimeters at 53 north. What is the scale of the chart at 30 south? At first sight, it seems that the solution is to find the scale at 53 north, and then do a Mercator scale change to 30 south. Many students will do this and will therefore waste time in an exam. The question is there to see if you can pick out the essentials. The point is that if the east-west chart length is 133 centimeters at 53 north, then it is also 133 centimeters at 30 south. On a Mercator chart, the scale changes with latitude, and the departure between two meridians changes with latitude, but the chart length does not. The meridians are parallel. Just solve the problem at 30 south. Find the departure between 180 degrees west and 180 degrees east at 30 south. That's 360 degrees change of longitude times 60 to convert to minutes, and then multiply by the cosine of 30 degrees, which is about 18,700 nautical miles. The chart length is in centimeters, so multiply this departure by 1852 and then 100 to get the Earth distance into centimeters as well. Now find the representative fraction in the usual way. The scale is chart length over Earth distance. Chart length is 133 centimeters, and we've just found the Earth distance. So the answer is about 1 to 26 million. So, to summarize, the ATPL syllabus requires you to be able to carry out Mercator scale change calculations. These calculations divide into 4 main types of problem. They are Given scale at the equator, calculate Mercator scale at some other latitude. Given Mercator scale at some other latitude, calculate the scale at the equator. Given Mercator scale at some latitude, calculate the scale at some other latitude. And given a fixed chart length between two meridians, calculate Mercator scale at a specific latitude. These are solved by one of two basic Mercator scale change formulae. The first is scale at any latitude equals scale at the equator times secant of the latitude. And the second is we get denominator A over denominator B equals cos A over cos B, which is often more usefully expressed as denominator A equals denominator B times cos A over cos B. Finally, there are problems where the chart length between meridians is given for a particular latitude. These can be solved either as a Mercator scale change problem or as a departure problem.